All right, so now we get to part three of this first part of this section 6.2. So we actually have two assignments with this section, and the first half is divided into three parts. So this one is as tricky as it gets for this part, I guess. So instead of rotating around the x or y axis, what if we rotate around a different axis? So y equals 1. So horizontal line y equals 1, horizontal line y equals 2, or the vertical line x equals 3. And so most of these are going to be using the washer method, but it doesn't have to be. It could still use the disk method. Everything works the same. It's just sometimes, well, when you're on an axis, when you're rotating around an axis. So we'll draw something here. So let's say we have this area, and we're going to rotate around this line. So this creates a washer, and we're going to rotate this around this. So we have this gap in here. And so now our cross section, instead of being like this from the curve to the x-axis, we got this extra space in here. So it's not just, if this is square root of x, it's not just square root of x. And let's say this is -1. What is that distance from all the way from here all the way down to there? Well, it's square root of x plus 1, which is the distance here. So you got to take into account that. I don't really like the idea of giving a formula for this. I think it's much better to be able to draw this picture and then see what exactly are you measuring. And so here the outer radius would be square root of x plus 1. That's the total distance. The inner radius would be just 1, because we're going from 0 to -1, which is a distance of 1. So always think about this. Radius is a distance, so always think about it in that way. Okay, so let's look at this first one. So we have y equals x squared around the line y equals 2. So now, in the previous videos, I said if you're rotating around the x-axis, you need things in terms of x. If you're rotating around the y-axis, you need things in terms of y. Now, you see this and you think, okay, I need things in terms of y, but that's not correct, because y equals 2 is a horizontal line that's parallel with the x-axis. So you still need things in terms of x. So when it's y equals some number, you still need things in terms of x, and you can remember this because your cross section will still be perpendicular to whatever you're looking at. So let's draw this picture and see what it looks like. So we have y equals x. We'll just stay in the first quadrant. That's all we need. Now I would figure out where your intersection point is before I draw this line, because you don't want this line. This line is actually going to be up here. So let's make sure. So we have x equals x squared. And again, I think we did this one in a previous video, 0 and 1. So y equals 2 is going to be up here. So now we're rotating around this axis. So the y equals 0. I keep making that look like a G, but it's rotating. It's a rotation. It's rotating around this. All right, so how do we do this? So here is our cross section, but we really need all the way up to here. We need to think in terms of that. So we have volume is pi. This goes from 0 to 1. Now, what is our outer radius? So from here, that's our x squared, up to 2. So what is that distance? Well, the distance from here to here would be 2. And whatever this is, that is x squared. And so we need to subtract off the x squared part. So we have 2 minus x squared. We got a squared, of course, because it's the radius. Minus, now, from here to the inner radius, we have 2 minus x squared, because it's the radius, dx. All right, so let's multiply all this out. 4 minus 4x squared plus x to the fourth minus 4 plus 4x minus x squared. So I went ahead and distributed the negative just to save a little bit. Combine like terms if you can. Let's see, that's gone. And then negative 4x squared minus x squared. So we got negative 5x squared plus x to the fourth plus 4x. Integrate, so negative 5/3 x cubed plus 1/5 x to the fifth plus 2x squared. Plug in your limits, and you should get 8 pi over 15. Okay, so again, the important part is getting this set up. Make sure you can understand where we got the outer radius and the inner radius. So it's 2 minus whatever the function value that gives you the distance from here to here, or from here to here, whichever the case may be. All right, let's look at another one. So we got y equals e to the negative x, y equals 1, x equals 2, and y equals 2 again. All right, so e to the negative x is going to look something like this. That, of course, is going to be at 1. Y equals 1, so that's coming like this. X equals 2 is coming like this, so we have this shaded area. There's our enclosed area. And so we always know, I haven't really mentioned this, but you always know where to shade because it's the closed area. So that's the only place that you're going to need to shade. And then we're going around y equals 2. So y equals 2 is a horizontal axis, so we're thinking in terms of x still. So now, clearly we're going from x equals 0 to x equals 2. So the volume is pi, 0 to 2. And so what is the distance from here to there? So 2 minus e to the negative x squared. And then what is the distance from here to that one? And that's just going to be a 1. That's constant. So this is a constant function. So the distance between here and here, no matter where you move along, anywhere between 0 and 2, that's just going to be a distance of 1. So let's just do a 1 squared. And we'll multiply all this out. 4 minus 4 e to the negative x plus e to the negative 2x minus 1 dx. And I won't combine these. 4 minus 1 is 3, so we'll just go ahead and do the integration. So 3x plus 4e to the negative x minus 1/2 e to the negative 2x from 2 to 0. And you're not going to get a nice simple answer on this one, but that's okay. Plug in the 2. We get 6 plus 4e to the negative 2 minus 1/2 e to the negative 4, and then plug in 0, so that is 0. And then plus 4 minus 1/2, since e to the 0 is always going to be 1. And so then that gives us pi. 6 minus 4 plus 1/2 is 2.5, so we'll just say 5/2 plus 4e to the negative 2 minus 1/2 e to the negative 4. And then there's our answer. So let me just say something about this answer, because some people are uncomfortable maybe putting that into WebAssign. I don't think any of these in the homework ever tell you to give the rounded off answer. So you're never going to put these answers in your calculator to get a long decimal. So don't ever do that. And the only time you will do that is if it ever says round off, enter your answer, round it 4 decimal places or something like that. If it does not tell you to round, and most of these are not, because it's not really the point of this class to get some numerical answer. Like, we don't really care what the numerical answer is, except how did we get there? That's the more important part. So get used to and get in the habit of leaving your answers. I mean, this is simplified, but as an exact answer, not as an approximation. So when you put this in the calculator and you, whatever number you put, it's an approximation because this number is irrational. It goes on forever. You can't type all the digits. So whatever you put in is an approximation. So I want you to get used to putting answers in as their exact form. All right, the last one. So we got y equals x squared, x equals y squared, around x equals -1. So this is vertical, so we need things in terms of y in this case, because this is a vertical line, and we're going to be measuring horizontal cross sections. Okay, so y equals x squared. We obviously know it's something like this. X equals y squared is just going to be the sideways parabola. And so there's our shaded area. And we are rotating around x equals -1. Oh, that's not x equals -1. X equals -1. This one. Don't worry about that one. Okay, so x equals -1. Now, we need this in terms of y, or in terms of y. So let's write this as, and we can just say square root of y because we're only on the positive side. Technically, if we were graphing the whole thing, we would need x equals negative square root y, but we're only in this first quadrant, so the positive part is good enough. All right, so we have volume equals pi. Now, when we say from 0 to 1, that ordered pair is 1, 1, so it doesn't really matter if we mean x or y. We're putting this in terms of y, so these are actually y coordinates. So if it was 1, 2, you need to put the 2. So 0 to 1. What is the cross section from -1 up to? So that is y equals x. No, let's write it the way it is. X equals square root y, and then this one is x equals y squared. All right, so we are going from -1 up to square root y. So that distance is square root y plus 1. So from here to the y-axis would be square root y, and we're going another unit beyond that. So we have square root y plus 1 squared minus, now from here to here, plus the extra unit. So really from here to here, that is y squared plus 1. So y squared plus 1 squared dy. And now it's just a matter of multiplying all this out. FOIL out square root of y plus 1 squared. So we get y plus 2 square root y plus 1 minus, FOIL out this, we get y to the 4th plus 2y squared plus 1 dy. And let's see, the ones will cancel, nothing else combines. Actually, let's not write the integral again. Let's go ahead and integrate it. So 1/2 y squared plus 4/3 y to the 3/2. The 1 cancels with that one. So minus y to the 4th, we'll integrate that. 1/5 y to the 5th minus 2/3 y cubed. And from 0 to 1. And then we plug in the 1. 0 is obviously going to make everything go away. Plug in the 1, just double checking. I got the right, and it should be 29 pi over 30. Okay, so that's first half of section 6.2. You got any questions, you can let me know.